Okay guys, today we're going to be going over the Unit 3D Newton's second law, part 2, practice problems from Physics in Motion on GPB. So you should have already watched the video notes for frictional force and static and kinetic coefficients of friction, but just to give you a reminder, our formula that we're going to be using for these problems is going to be frictional force is equal to mu, which is our coefficient of friction, times our normal force. So number 1 says a 20 kilogram block slides across a horizontal surface. The first thing that we're going to write down is that our mass is 20 kilograms. If the coefficient of kinetic friction between the block and the surface is 0.2, so mu is 0.2, what is the force of kinetic friction that acts on the block? So we're looking for the force of friction that acts on the block, and that is measured in newtons. So the first thing that we have to do with this problem is figure out what our normal force is. So since it's on a surface, we know that our normal force is going to be equal to our force due to gravity, which is also known as our weight. So how we're going to first find that normal force is by doing F equals ma. Our force is what we're looking for. Our mass is 20 kilograms. And then we're going to multiply it by 9.8 because that's our acceleration due to gravity. So we go to our calculator. 20 times 9.8 is equal to 196. So our normal force is 196 newtons. So after we have our normal force, now we can use the equation of frictional force equals mu times normal force. So we're going to reset up that problem. And we're going to solve for frictional force. So frictional force equals mu, which is our coefficient of kinetic friction, which is 0.2, times our normal force, which is 196. So we're going to multiply 196 by 0.2. And we get 39.2 newtons for our frictional force. Going on to number 2. Number 2 says the coefficient of static friction between a 2.5 kilogram block and a rough surface is 0.8. What is the maximum static frictional force that can act on the block? Maximum just means that we're looking for the amount of force that can be applied to the block before it starts to move. So the reason that it says static is because they are informing us that the object is not moving. Whereas in number 1, they told us it was the kinetic coefficient of friction, which means the box was moving. So in this case, what we're going to do is the exact same thing, where the first thing that we have to find is our normal force before we can solve for our frictional force. So our normal force formula is going to be F equals ma. Force is what we're looking for, equals mass of 2.5 times 9.8, because that's our acceleration due to gravity. 2.5 times 9.8 is 24.5, so our normal force is 24.5 newtons. So now we can go ahead and grab that formula that we learned from that last video, and we're going to do force of friction equals mu times normal force. And we're looking for force of friction. Our mu is going to be 0.8 because that's the coefficient of kinetic friction. 0.8 times our normal force of 24.5. Multiply those together using your calculator. And your answer should be 19.6 newtons of frictional force. And since it's asking for the maximum static frictional force, we're going to write greater than or equal to. So the maximum static frictional force that can act on this block is going to be less than or equal to 19.6 newtons, because this is the max that it can get before it will start to move. Number 3 says a 1.5 kilogram block is pulled across a horizontal surface that has a coefficient of kinetic friction of 0.6. So our mass is 1.5 kilograms. Coefficient of kinetic friction is 0.6. What is the force of friction exerted by the surface on the block? So again, we have to figure out what our normal force is first, and then we can find our force of friction. So we're going to do F equals ma, force equals 1.5 times 9.8, which is our acceleration due to gravity, and our normal force is going to be 14.7. So now we can use our frictional force formula of frictional force equals mu times normal force. Frictional force equals mu, which is 0.6, times 14.7. Frictional force is going to be equal to 8.82. And that's measured in newtons. Once you start getting the hang of these and remembering what formulas to do, this worksheet will be pretty simple. You just have to make sure that you know to find the normal force before plugging in for this formula. So B says if the block is pulled by a 12 Newton force, what is the net force acting on the block? So it's asking us if the block is pulled by a 12 Newton force. So here's our free body diagram for this. 12 newtons going this way is our applied force. And our net force is going to be the difference between the friction and the applied force. So our frictional force that we just found in the previous question was 8.82. So F net is going to be equal to applied minus the frictional. So F net equals 12 minus 8.82, which will give us 3 something. Go to your calculator. 12 minus 8.82 is 3.18. 3.18 newtons is our net force. Now it's asking what is the acceleration of the block. So acceleration, you're going to find that using F equals ma. So the net force that we're going to be using is that 3.18 newtons. So F 3.18 newtons, mass was 1.5 kilograms, and acceleration is what we're looking for, and that's in meters per second squared. So when we set up this problem, we're going to use F equals ma. Force is 3.18 equals 1.5 times acceleration. To get the a by itself, we want to divide by 1.5 on both sides. So 3.18 divided by 1.5 is equal to 2.12. So our acceleration equals 2.12 meters per second squared. Number 4 says a 2 kilogram block is pulled across a horizontal surface by a 15 Newton force at constant velocity. So if it's being pulled across a horizontal surface by 15 newtons of force as a constant velocity, then we know that the applied force and the frictional force have to be the same because we're moving at a constant velocity, which means that we have balanced forces. So our free body diagram is going to look like this. And that is 15 newtons. Frictional force is going to be also 15 newtons because they have to cancel each other out. And these will also be equal, the normal force and the force due to gravity. So what is the net force acting on the block? Anytime you see that the block has constant velocity, your net force has to be 0 newtons. And that's because they're balanced. What is the force of friction acting on the block? We know that since they're balanced as our net force is 0, our force of friction has to be 15 newtons because our applied is also 15 newtons. What is the coefficient of friction between the block and the surface? So for this one, we're going to be solving for mu. So force of friction equals mu times Fn, which is our normal force. So before, just like we did on the previous side, we have to figure out what the force due to gravity is. So we're going to take F equals ma. Our force due to gravity equals 2 times our acceleration, which is 9.8, sorry. Just had a total brain fog. 2 times 9.8 is 19.6. Force due to gravity is 19.6 newtons. So we're going to come back up here to find frictional force, which is 15. Mu is what we're looking for. All right, so now that we know that our force due to gravity is 19.6 newtons, our normal force also has to be equal to 19.6 newtons. So from there, we can just plug in for frictional force equals mu, which is what we're looking for, times normal force. Frictional force is 15. 15 equals mu times 19.6. So mu equals whatever 15 divided by 19.6 is, because we want to get mu by itself. So 15 divided by 19.6 is 0.77. So mu should be 0.77. Okay. Number 5 says a 1 kilogram water balloon falls downward and experiences a 4.9 Newton air resistance as it approaches the ground. What is the acceleration of the water balloon when it experiences this air resistance? So we know that the water balloon is falling downward, and it's going to be our force due to gravity, and it experiences 4.9 newtons of air resistance, and that's just our force of resistance, and that is 4.9 newtons. As it approaches the ground, what is the acceleration of the water balloon when it experiences this air resistance? So we have to figure out what the acceleration is. So our formula is just going to be F equals ma. We know that our mass of the water balloon is going to be 1 kilogram, and our force is 4.9 equals 1 times acceleration. Divide by 1 on both sides. 4.9 divided by 1 is obviously going to be 4.9. So 4.9 meters per second squared equals A. So that just means that the acceleration of the water balloon when it experiences this air resistance is going to be 4.9 meters per second squared as it goes to the ground. What force is necessary to pull a 10 kilogram sled across a horizontal surface at constant velocity if the coefficient of kinetic friction between the sled and the ground is 0.25? So the first thing that we're going to write is our givens. So our mu is going to be 0.25. Kind of looks like a 6, doesn't it? 0.25. And our mass is 10 kilograms. And we need to figure out what force is necessary to pull that sled across a horizontal surface at a constant velocity if the coefficient of kinetic friction between the sled and the ground is 0.25. So we need to figure out what the frictional force is, and then that applied force should be equal to the frictional force because it's a constant velocity, so it has to be balanced. So to figure out what the frictional force is, we're going to use that same formula of frictional force equals mu times normal force. But before we can do this formula, we have to figure out what our normal force is. So we're going to take this mass and use it for our F equals ma. So force due to gravity is what we're looking for, equals 10 times 9.8. Force due to gravity is 98 newtons. So that means that there are 98 newtons traveling, or of force pushing down. And since this is balanced and moving at a constant velocity, and we're staying on the surface, we know that our normal force is equal to our force due to gravity, so our normal force is also going to be 98 newtons. So we can go back to this problem of frictional force equals mu times normal force. Our mu was 0.25 times 98, which is our normal force. 0.25 times 98 is 24.5. Our frictional force should be 24.5 newtons. Number 7 says, what is the acceleration of a 10 kilogram block that experiences a 50 Newton applied force as it slides across a horizontal surface where the coefficient of kinetic friction between it and the surface is 1, or 0.1. So we've got our mass is 10, and then our applied force is 50 newtons. It's sliding across the horizontal surface where mu is 0.1, and we're looking for our acceleration. So the way that we're going to find this first is by finding the frictional force. So the frictional force is equal to mu times normal force. Obviously, we don't know what the normal force is, so we have to find the normal force, which is equal to the gravity force. So normal force equals mass times acceleration. Fn equals 10 times 9.8, because that's our acceleration due to gravity. Normal force, again, is 98 newtons. So frictional force is Ff equals mu, which is 0.1, times normal force, which is 98. 0.1 times 98 is 9.8. Newtons. So we know that our frictional force is 9.8 newtons, but we have to solve for acceleration. So the acceleration problem that we're going to use is still going to be that F equals mass times acceleration, but the force that we're going to be using is that frictional force. So 9.8 equals mass, which was 10 kilograms, times acceleration, which is what we're looking for, divide by 10 on both sides. And our acceleration should be 9.8 meters per second squared. And that's it. Totally kidding, I forgot that there was a back. Okay, a 25 kilogram sled is pulled across a horizontal surface by 200 newtons of force at constant velocity. What is the coefficient of friction between the sled and the surface? So we've got a 25 kilogram sled. Applied force is 200 newtons. It's constant velocity, so our frictional force should also be 200 newtons. And we're looking for mu. So the first thing that we're going to do for this problem is find our normal force, which is going to be equal to our gravitational force. So we have to find F equals ma. F equals 25 times 9.8, because that's our acceleration due to gravity on the Earth. Our normal force should be equal to 25 times 9.8, which is 245 newtons. So now we can do our formula for frictional force equals mu times normal force. Frictional force is 200 newtons. Equals mu times 245. The way that we solve for mu is by dividing by 245 on both sides to get the mu by itself. 200 divided by 245 should give 0.82. So your coefficient of friction between the sled and the surface should be equal to 0.82.